You know, I've been thinking, is there a better way to the current Geneva Film Advanced system? Well, it turns out there is. This is my newly developed Film Advanced drive system. It consists of a NEMA 17 stepper motor, a 3D printed and directly driven sprocket drum, and a film table construction for testing purposes. It's a direct replacement for the previous Geneva mechanism. While the Geneva mechanism works, it's rather limited in its frames per second range. It's only capable from going 10 to 24 frames per second, and its quite complicated design and assembly aren't very practical for any further development or production. I've also wanted to shoot with crystal sync frame rate speed and reduced running noise. This design is also much simpler and more robust with fewer parts, and this design offers an extended frame rate range from 1 to 30 frames per second, better frame stability and a more reliable operation with pin registration. Now before we continue, here's a quick video montage of the stepper assembly and construction. For the past few weeks I've been also experimenting with my newly bought 3D printer, setting it up, making an enclosure, and calibrating it to work with ASA filament. This camera's housing, as you may remember from my first video, is made from 3D printed PLA plastic. It's a good choice for rapid prototyping and testing, but it fails as an outdoor device due to its UV and high temperature intolerance. What happens is a fast structural degradation and softening when exposed to the sun. Just imagine leaving the camera in the sun or in a hot car for a few hours. The housing and the internal structure would deform, causing the camera to become non-functional. An ASA plastic, on the other hand, is much more suited for production due to better mechanical properties and being UV and high temperature resistant, making it a good choice as an outdoor product. Printing with ASA plastic is quite hard as it really likes to curl up in the corners. I solved this by making a DIY enclosure, hot printing environment, and some special settings. The sprocket drum features an infrared slot detection system. It serves as a frame position detection and frame counter, so the system knows the horizontal position of each frame and serves as a film runout detection or film jam detection. In the photo mode, the system advances by one frame after each shot, also useful for stop animation. Also, this button will be replaced with a new one. In the movie mode, the frame positioning with pin registration is much better just by looking at the sprocket holes. The stepper can also run in intermittent and continuous rotation, making it useful for both shooting and film scanning. My next task is the development of the main printed circuit board, or you may call it the brain of the camera. Here I will be reducing the board size and optimizing component selection for better camera overall price reduction. It will also contain new things such as Bluetooth connection for smartphone scanning, a USB-C port charge connection, and other improvements But until then, stay tuned for more. You can support the project by liking, sharing and subscribing to my YouTube channel. Also, please visit my website if you haven't already for more project information and details. The link is in the description down below. I'll try to keep you updated more frequently. Thanks for watching and see you soon. Bye.